Hi, everybody, and welcome. I'm pleased to be here with you at HashiTalk Secure 2024. I wore my Hashi socks, but y'all can see it today because I'm not that fit. My name is Kosseila. Today's topic is compliance as code in Terraform. Okay, I can't do it again. It's fine. Hi, everybody, and welcome. I'm pleased to be here with you at HashiTalk Secure 2024. My name is Kosseila. I wore my Hashi socks today, but y'all can see it because I'm not that fit. Today's topic is compliance as code in Terraform with Checkov by former BitchQ, now Prisma Cloud. And I'll be giving you some context before diving into Checkov, of course. But first, just a quick intro, if I may. My name is Kosseila, aka Cloud Dude. I'm a solution architect at Eclipsis here in Toronto, Canada. I have a little more than a decade experience in IT and Oracle Tech. I've been a DBA for a long time until I got bored and transitioned into multi-cloud ops and IIC the last 5 years. There is no much more to say that I am a huge cloud and automation fan, and I share all my labs and discoveries on my blog, brocktba.com, and in my GitHub repos, so that's github.com/brocktba, so check it out. And I'm also the host of a podcast called Tech Beats Unplugged since August, which I'm very excited about, so please check it out. You can find a cool episode where I hosted Kelsey Hightower, and we talked about and chilled about DevOps for about 2 hours. So please check it out. This is the QR code. Right. So now that we're done with the intro, let's get to the reason why we all here today. All right. What are we going to talk about today? Well, first, we'll talk about a bit about context and compare some misconceptions and challenges that come with compliance before and after DevOps, meaning old school versus new school. Then we'll review the state of IIC source misconfiguration through study report. And in section 2, we'll have small introductions on available compliance as code solution, whether it's standalone, SaaS, third party, or open source based, because I did some research. We'll then go through some concepts of Checkov, features, benefits, such as seamless integration with CI/CD before exploring these capabilities with a demo in Terraform. In section 3, we'll describe Checkov integration in pipeline workflow in general and the best strategies to leverage it, which will be followed by how to show the pretty HTML report or of the scan result in GitHub and Azure DevOps. After that, we'll see a demo with a full GitHub action workflow, included in directory scan and HTML report. And also, we'll talk about branch protection, how to use Checkov actually in order to do that effectively. And finally, we get to Q&A if we have time. We never know. So let's start with the meme, right? Of course, your bosses have many expectations when they hear you're a cloud engineer, right? But this is my face when my boss asked me to convert more than 300 security controls from Canadian security compliances into cloud policies in Oracle Cloud Landing Zone. Why? Because this is just a use. It's a lot. 300 control are just a lot. 18 categories. It's just for the ops today with all those categories and guardrails and all those regulation for an ops person is just too hard to do that from scratch alone. It's not a single person's job. It's more like a service provider or even a vendor's job, right? So bottom line, it didn't happen. We waited for the new version of the landing zone that would actually support all that, right? This is what's just one little anecdote that I had. But if it's not us, then who? Like usually it's the security folks, right? So let's talk about security folks. Security departments used to be called the Department of No. No, you can do that. No, you won't have that, and so on. That was the good old days, the on-prem days, when they had full controls of the racks. But today, with the public cloud infrastructure APIs, gloves are off, and nobody begging for resources behind Jira tickets. All days are actually gone, and now it's open bar, and with DevOps and new software supply chain, devs will deploy with a huge velocity and way faster. But we still need to secure that. We still need to secure our infrastructure. The problem isn't gone. Now, depending on the organization, we see two trends. The first one is when security team is playing catch up with what the devs already pushed in production, which is kind of reckless because it's too late. And the second scenario is when companies enforce strict procedure where even with beautifully automated pipelines, there's a review step by security team for approval, which is the sign off, that actually you just go into block or jam this agility. That's also bad because these people can't remember thousands of policies and configurations to control for each cloud provider. Nobody can actually. Nobody know them by heart. This is why instead of mainly focusing on security tools to security people, a new type of solutions, this is the spoiler, emerged to provide a whole new perspective where we give ownership to developer. And that's what we call shift left, right? Especially when we know that 95% of the cloud security issues are related to misconfigurations, not CVE, but misconfigurations like for the LastPass breach last time recently. But there's more, as I want to show more numbers about the source. So let's talk about the source. Where do you get your Terraform configs? It could be a friend. It could be Stack Overflow, which is not a friend. It could be Terraform registries, modules, even ChatGPT. This is because everything has become declarative with DevOps and Terraform, and we definitely use external module templates every day, whether these templates come from a CSP, vendor, or any open source developer. So let's check how secure these Terraform templates are. Well, according to Unit 42, which is a research team at Palo Alto that used Checkov to analyze almost 5,000 modules templates from registries and popular GitHub repos and 38,000 files, right? Turns out that overall, they found out that 63% of the Terraform templates contain one or more insecure configuration. It could be anything, though. No, we don't know how serious it is. But on the other side, in the meantime, 49% of the templates contain at least one critical or highly insecure configuration. This is serious, right? Because that's nearly 1 in 2 modules within Terraform registry that is misconfigured. And these misconfigured modules, guess what? They have been downloaded over 20 million times, and that's in 2021. So imagine today, right? And when we hear about 20 million downloads, that doesn't mean 20 million deployment, because you download one, their modules, remember? So this is why they're built. They're built to be reused and re-executed, right? So you may have like 10 times that number, right? Or 100 times, right? So that could be 20 times 100 is 2 billion. Crazy. That's scary. And the most common misconfigurations are in the general security, login, and encryption categories. But what you need to remember is that Terraform is not the only code that's impacted by this plague. All the declarative artifacts are also misconfigured, like Helm charts, for example, which is the most popular tool for deploying Kubernetes applications. In that research, 618 Helm repository with more than 2,300 charts, what they found out is that 71% of those scanned repositories contain misconfigurations, and almost half, 46% of the 2,300 scanned Helm charts and their dependencies contain misconfiguration. So this goes to show that the default templates you find online are not secure and can be used as is, right? Same thing with images, right? But then what can we do about it, right? Well, fortunately, a lot of open source projects and third parties start to address the challenge. And so I did some research, and I would like to share with you and show you the available compliance code solutions in the market and their types, because there are many, right? First, we got OPA, which is a policy-based control framework for cloud-native environments. You'll have to use Rego, which is I'm not super fan of, to build your own policies, and they have few projects that are dedicated to Terraform, such as Styra, which is behind OPA, Styra DAS, Declarative Authorization Service. That's a SaaS solution supporting validation in Terraform code and plans via pre-built system type. Then you got Scalars, Spacelift, Terraform Cloud, like Sentinel, that are all SaaS solutions, so it's not open source. And then to be honest, Rego is not the most readable. That's just to stay kind, because it's a zillion miles away from SDL or HCL. All right, and sometimes you need to write those 300 security controls now and not in 3 months. So you want to have something that's ready with built-in policies. This is why we see a different type of static analysis scanners for IAC Terraform from Terraform ecosystem, such as TerraScan, both TFSec and Trivi that come from Aqua Security. So TFSec is maybe discontinued, so Trivi is like the main project maintained, and Terraform compliance. Right, I tested them all, so you got pros and cons out there. And finally, you got the main scanner, which is our main scanner today, which is Checkov by BridgeQ, bought by Prisma Cloud from Palo Alto Networks. Okay, so before comparing, let's talk about Checkov, or more or less, why Checkov, right? So Checkov is a static analysis tool that helps detect security vulnerabilities and compliance issues in IC files like Terraform, CloudFormation, Bicep, and much more. And also, it's the only one that supports all cloud providers, including Ali Cloud and OCI, which is not supported by the others, right? It's written in Python and scans your config file against security best practices. So it supports Kubernetes, Helm charts, Docker, Kustomize, GitLab, GitHub, Ansible, and it's by far the most comprehensive open source. 3,700 built-in policies and just only 2,000 just for Terraform. Right, that tells you like how comprehensive it is. It actually supports also secrets and credential detections. Has extensions with CI platforms like Git and Terraform Cloud, and has the VSCode plugin, and it's been downloaded actually more than 38 million times since 2019. Right, so that's the power, I'd say, and it also has Visual Studio Code plugin, right? One other feature I want to talk about is dependency aware graph in-memory graph mapping that would just actually allow you to graphically read through a complex network of dependency in order to make sure the deployment is compliant. And this is since Checkov 2.0. So I really like this feature because it can go deeper in the relationship between the components you're actually deploying. So you can see the type of extensions. You got Kubernetes, manifest, YAML, JSON. You got Docker file, container file, Terraform files, TF JSON, TF vars, and plants as well. CloudFormation, same thing with ARM templates and Helm charts, right? Go back to the benefits in multi-framework, multi-cloud support, and provide ingestible scan data. That means that you can see a graphical version of those checks and their results, right? It supports NIST, CIS, all the known standards. Seamless integration with CI/CD. Why? Because it's just a CLI, so you can literally put it in any CI pipeline, because it just like a CLI object that you need to download and run. What else? You got the VSCode plugin, and you got pre-commit support, which is super cool. I like pre-commit because it runs, especially the local one. I don't like much the action one, but the support pre-commit that would allow you to locally scan your stuff before pushing them, and like avoid pushing your code directly if it's incompliant. It's even integrated with the ChatGPT. If you want to add the API key and then give more enhanced findings to your result, you can go for it too. And also, you can actually read into the logic of your Terraform code, right? For each loops, 90-minute blocks, it actually reads that. So that's the cool part of it. It's not just reading like static blocks. Installation is pretty straightforward. Pip install, brew install in Mac, Docker. You can run it through Docker as well. VS Code plugin. Well, that's the cool feature by far, because integration with IDE, with an IDE plugin, they have that for IntelliJ too, allows you to scan misconfiguration from the first line you actually write in, which is super cool, right? And it will allow you to detect the secrets and do actually the check on the fly, right? So you can have a contextual display while you're writing. It will just scan your folders live. The extension will just scan that wherever you're opening the files within the folder. It will scan and to tell you, as you can see here, the list of checks. And the best part is the suggestions, the fixed suggestions. So like you can click and add whatever necessary configuration in order to get rid of that non-compliance, right? If it's something, a flag actually that you need to flip, or a feature that you need to enable, you don't have to write it yourself. That's the best option. The only bummer is that you need an API key of Prisma Cloud. So that's about it. But if you guys are interested in the version that doesn't require the API key but doesn't have the fixed part, just reach out to me. I can hook you up with something. Right. So as I said, you got the fix, and now I want to talk about the commands. Obviously, you need to know the commands. And the first time I saw the command list display, it was intimidating. It was really confusing last year. So I couldn't wrap my head around the content, and it was pretty cryptic. This is why I would not do that today. So I'd rather just explain few useful commands, even without running them, and flags, so we can focus on just what matters, if that's okay with you. So the first one is D. So -D or directory would just specify the root directory that you want to scan, right? You have also the -F or file if you want to just run the check on a specific file. You got to know that some tools, I told you I tried other tools too. So some tools like Trivi aren't recursive by default, right? You have to enforce it in the command, right? And Trivi has 1,403-ish policies, which is way far than 4,700. Obviously, yeah, you can guess the non-support of Oracle Cloud and Alibaba Cloud as well. And you got Terraform compliance that is relying hugely on the plan, right? So if you don't have the TF plan with Terraform compliance, forget about it. You cannot run it. What else? We have the framework. Cool thing about the framework is sometimes you're in a monorepo. In a monorepo, well, you got Terraform, you got Docker, you got Kubernetes, you got everything. And what you don't want, especially in a workflow, you don't want your build or your check like spend 80% of your build time, right? Like people get mad at you actually if you do that, right? So if you're just in a workflow, you just want to test Terraform, then you would specify framework Terraform, even if you have many other files that could have been scanned by Checkov otherwise, right? So that's reducing the amount of time you're doing the check. Why? Because you're specifying the kind of check in like a repo that has way more frameworks, right? After that, we have quiet. This is one of my favorites. I use two, actually. This is part of it. So the quiet will display only the fail checks. Like nobody cares about the pass checks. It's good to know that it's safe, that we pass them, but like, who cares, right? So if you put quiet, it will just show you whatever is failing, right? The next one is compact. Compact, why compact is good and why I do like these two, especially when I get into a new folder and I want to check it. I want to reduce the verbosity of my output, right? So what does compact do is it's not going to display the snippet of the block that is impacted. Why? Because sometimes you have, for example, same resource written 20 times, and this resource has the same error, the same type of error, same check that is failing, right? So instead of, do you want to actually see the snippet for those 20 resources in your big file? No, obviously. You just want to know what type of check, and then you can like just go and check that resource afterwards. So this is why the first time I run it, I use the quiet plus the compact. That way it would allow me actually to reduce the amount of content that is displayed and pushed by Checkov, right? Check, same thing, not same thing, but it's another feature that will allow you to be more specific. So you can use check, a code check, specify like a check that you want to run. For example, you don't care about anything else than encryption. So you put anything that's related to encryption in that list. It could be delimited by a comma, right? So anything related to AWS encryption, you put it there. So you don't care about the rest, right? You can do that with severity. You can say, like, for example, like I want to check medium. What does that mean? Is that like Anything over medium will be checked. Anything under medium will not check. Only bummer is that, well, you need an API key, right? So forget about it if you don't have an API key. You have Softwell as well. Softwell is good for framework. I would say like pipelines. So if you have a workflow and you don't want it to fail, maybe it's the first run, so you don't want it to fail. You just still want to see the check results, but you don't want to fail your task or your job. So you put Softwell that way, like it would complete successfully. You'd still have the result, but nothing will break. Like a workflow would just go run to the end. What else? We have the skip check. Same thing with check. You can use severity, but then you need the API key. But let's say, for example, I want to avoid these checks because they're not really relevant for me. So I can put that. I put a list. And list is good. Sometimes you want to be curious about a specific framework. That's why I can use it. I can combine it with framework. That's good, because if you do just -L, you'd have the 4,700. It doesn't make sense. So you run -L with framework, for example. Maybe not Terraform. Maybe you can use Kubernetes, or you can use GitHub CI. You can see like how many checks they have, and they have the links, all the descriptions. So that's kind of cool. All right, one more thing I want to talk about. Like, there are two more features I really want to highlight because I get these questions a lot. What happens if you want to skip existing misconfiguration? Because they're okay, but there are so many that they can't fit in your skip check, right? You got 100. You can't put in a one-liner. There's no way you can run Checkov with those 100 check to include or to skip. So what do? You actually just have to use baseline. So Checkov has something called baseline that would allow you to skip existing misconfigurations in the future scans. So once you made sure that you fixed all the most critical checks on your directory. I'm not saying like you will ignore everything, but like once you cleaned it up a bit, anything that's not relevant, but if there are a lot, like 100, you can create a baseline. So you can create a baseline by running Checkov IDE, the directory, and the create baseline flag. And this will store all the remaining failing check in the snapshot, right? Next time you run, so next up you keep adding new resources, but in your scan, you would use the baseline to ignore the old checks and just focus on the new warnings, right? So that will allow you would literally just tell Checkov, you know what, whatever was running in the past, based on this baseline, just don't show it to me. Just show me anything that's new. That's the cool part of it, because some people may have some issues and troubles when you have especially 2,000 checks for Terraform. The second one is custom policies. Obviously, it doesn't mean that what OPA does doesn't mean that Checkov doesn't do it, right? So what I like about this part is that it has custom policies, and the most interesting part about that is that it also supports YAML, which is way more readable than Rego. Am I right? So I hope I'm not the only one saying this. So you can see here the metadata with the attribute condition, including many operators like exist, and an OR logic, and regex, wildcards, JSON path expression. It has all of that, right? And the cool thing is that you can contribute back with this policy if you want to the project. Here, this custom policy is just ensuring that whatever you use as modules, you have to use the official AWS one, right? So yeah, this is making sure that you're only using Terraform AWS modules, for example. Right, so this is the demo. I know I'm supposed to do a demo right now. It's just about running the commands, but I want to talk about something before hitting the demo. All right, so I want to talk about shift left approach, because we're talking about GitHub, right? GitHub is in the title. GitHub Actions is in the title of this talk anyway. So the shift left approach, let's talk about it and what it really means with Checkov. In this basic diagram, we can see that Checkov integration is leveraged before triggering the deployment in your pipeline, right? This is more or less how it works, but that's maybe too generic. However, if you go deeper in your workflow, we can better spot the stages where Checkov can help you big time. Namely, number one, IDE. Why? Because IDE is like the first location where you put your first line of code when you get it from Stack Overflow, for example. So that's like the first front where you can act and avoid the misconfiguration of spread. And then you got number 2, pre-commit. What I like about pre-commit, the local pre-commit especially, is that you can just run your checks, especially in cases where, for example, you have secrets that you push. If you do that in a commit, you're done. Like your repo has to be rebased, literally, right? Why? Because you can see that even though like you remove the file with your TF var, you didn't put a git ignore of TF vars, but you put your AWS keys, you're done actually, because you go to the history, especially if it's a public repo, you get to the history of the commit, so you can see that key. So you're done. You have to rebase the repo. So why is it good? It's good because you can run that within your machine. It's not in an IDE, but it allows you to avoid pushing whatever stuff that is super non-compliant to your repo. And you just look good next to your team. So that's extra points, I guess. And finally, the commit. The commit, I say finally because the sooner your code is compliant, the safer and faster is your deployment lifecycle. Those are definitely the low-hanging fruits of misconfiguration you should focus on, because Checkov is the perfect tool for that kind of task, right? So as we can see here, the DevSecOps paradigm isn't much about how many teams, how many people we have, but more about where and when we can act, when we can automate all the security control assessment effectively. Right. So, and the last thing I wanted to mention was like a cool option, which is a pretty HTML report of Checkov scan results available for both GitHub Actions and Azure DevOps, and maybe other CI pipelines, thanks to Chekhov's output format. Right. In this example, the output is serif, so it would allow you to in GitHub Actions, you will have the scan results, not only in the logs, right, but also in the code scanning tab, which is nice, thanks to the action of Checkov, right? So that's the cool thing, where you can see it better than the logs. Scrolling through the logs sometimes with the hundreds and hundreds of checks, that's kind of hard. But if you go to code scanning section in GitHub after your workflow has run, that's even better. Checkov integrates beautifully with Azure DevOps as well. In this example, GitHub repo triggers your Azure pipeline through a webhook. And the good thing is that there is another format that's called GUnit XML, which is supported by Azure DevOps, right? And here in the pipeline, in the workflow, you just need to run the Checkov command, and then generate that GUnit output format, right? So when you run that Checkov with GUnit XML format, and after that, you just have to publish that scan file with the publish test result task. So it's another task that will just consume it and then process it, right? Same thing with TF plans. So Checkov can scan TF plans. You just need to convert the plan once you have it to JSON before running the Checkov scan using Terraform show, right? And at the end, you get the report will be shown on the build page next to the summary tab titled text, right? So graphically better than GitHub Actions, but I guess this is possible for other CI tools as well, right? So now we can go to the demo. Finally, we can go to demo. So let me just share my other screen. And if I do that, there is actually something I can do, right? Let me share the other screen, right? Let me share this, share screen, entire screen. I will go with this. Okay, right. So what I wanted to show is there's this one. Oops. Right. So there's a page. Maybe I'll publish it, but it contains the demo one. So the first demo that I wanted to run, I just wanted to showcase two directories. So the first one is TerraGoat, which is vulnerable by design Terraform repository by BridgeQ team, where you have AWS, GCP, Azure OCI, and Ali Cloud. The second one is BrokeDBA's Terraform example, which is me. With the same type of provider, Ali Cloud, AWS. So you don't have to actually go for something super misconfigured. Run it on your own deployment, and trust me, you'll be surprised. You'll find checks that were not satisfied for sure. Right. And the first example is the Checkov list framework. So you can list the policies. You can choose from this list of policies that you can run. Right. Let me see. Yes. So here I can actually just go here and then, for example, do this. Right. It may take some time, maybe like a couple of seconds. You can see here, look at 1, 2, 3, 4. We got 4 checks based on GitHub CI. They have GitHub repo as well. So you can do that. You can check. They have the links. That's kind of cool. What else? We have, so the TerraGoat repository, which is literally this one. Oops, no, not this one, which is literally this one. This is their repo. Right, so basically just have misconfigured repository, right? And I already cloned them, but I will run something for Oracle, for example. There's a folder inside, right? There's a folder here where inside Terraform, and actually I want to run the compact quiet. Remember, compact and quiet for just showing the failed ones, and compact is the one that wouldn't show the snippet of the blocks, right? As you can see here, you got ensure objects is encrypted with customer managed key. You got the resource here, right? You got the file, and you got the lines within the file, and then you got the link where they give you more explanation on how to fix it, why it's important to fix it, right? And if you want to do, for example, non-compact, you can see now that you will be seeing just the snippet, so the code, as you can see here, right? So you can see that bucket in here, for example, that just shows you like the basic behavior, right? If same thing with AliCloud, but if, for example, I want to try TerraScan, for example, on this provider, I want to compare with the others, right? Because I have them all installed here. Don't worry about it. See, it tells you they found 0 vulnerabilities with 0 misconfiguration. But it doesn't mean the directory is safe. It just means they have 0 checks related to it. Trivy, same thing. So AliCloud and Oracle Cloud, Checkov is the only one that has it. What else? See here, even if it's Azure, I run Trivy on the same repository on Azure, and I found just 100 checks that were detected, that were run, right? Versus Checkov that has 231. So like even if they support the same cloud provider, Checkov is the go-to tool because it's super comprehensive. Right. The second one is skip check. So sometimes you can, I'll use this just in order to show you the check. If I want to use the query or the check scan, right? I got to go to the second one, another directory, and I go Terraform example. Yeah, there we go. Terraform examples. This is my repo, right? This is what we have. AliCloud, same kind of stuff, right? But I wanna go to OCI, for example, Terraform provider, OCI, right? And then I just want to run it on an instance. So I had a bunch of lines, like a VPC, subnet, etc., an instance. And guess what? Like if I want to specify this one, it would just show me one, right? And I could remove the compact too, so it could show me. It will literally show me the resource, the block. But that's not what we want. We run it already. You can do that for secret specifically. This is the soft fail, so it's really self-explanatory, so I'm not going to run it. The nice one is the custom policies, right? So I'll have to go to another repo actually in order to run it, right? What does this one say? This one is actually just trying to check if there's any local exec or remote exec provision anywhere in your code, right? Wherever the resource, it will check if it doesn't exist. If it exists, then it will just throw that error check to you. So how do we do it? We go back to that repo, right? I'm here, right? Demo, and then I have to go to code, for example. There we go. And then I can run it. I can run it, and I will have to specify the directory where my YAML file is, custom checks. You don't need to specify the file, it's more the directory in question, right? This is exactly what I'm going to do, right? Checkov, I specify one file that has, I didn't show you the content, but it literally has like an EC2 with a, yes, with like a shady local exec. As you can see here, it tells you Terraform contains local exec or remote exec provisioner. This is that sneaky malicious code where it's literally echoing your access key to some file, SCP to some shady host, and remove it without you knowing, right? This is through YAML, so I really love this compared to Rego, at least personally. What else? So we have, you can do that with plans as well, but you require a plan. I don't have one right now, but this is how it works. You have to use Terraform show, convert it into JSON with the GQ after the pipe. And then you have the second one. The second demo was, I wanted to talk about the pre-commit, right? So basically pre-commit is super simple, not as complex as you would expect. This is my repo, the Checkov demo repo. You install it through pip install, and then you create your pre-commit config YAML. Pre-commit config YAML is just like an action that is going to run every time you're about to run your commit within your machine, which is the cool part, right? So, and it stops you from doing the push if ever anything fails. So we can have any arguments here. So this is the repo of our friend Anton Babenko that has a pretty extensive pre-commit Terraform list of hooks, right? And not just Terraform, many more. And then I just took I choose the Terraform Checkov hook script within this configuration, and I give it all my arguments, right? I give it quiet, skip check, or check, framework, compact, or the file I want to check eventually, right? So every time I try to push something, it will check this file. I could just keep it with the whole directory. So anytime I change anything, it will actually do a run of the Checkov based on that file. And then I have to do a pre-commit install, sorry, right? And once you run the hooks, after that, what you do is you modify one of the files, you do a git add, you do a git commit, and after that, it will tell you, no way, there's no way you can send this because, like, buddy, go fix it because there's a lot of errors here. I'm not going to let you commit it, right? But if it's not really vulnerable, it's okay, you know, or it's like just the first push and the checks were minor, you can always hit git commit, no verify. But again, you have to take care of it once it's here in your repo again through the pipelines, so the Checkov Actions, right? It doesn't mean like you don't have to clean, but at least like for the passwords and all that stuff, you can at least make sure it's clean, right? But you can always run it. You can run it manually. So what I'm doing here is I can run it manually here, literally, because I'm inside, and I can do pre-commit run A. And every time I do a commit, I'm just trying to simulate here. But every time I try to commit, those are like linters and everything, so it's not a big deal. But Checkov is failing here. And if you ever want to check something that you just modified and want to commit it, this failure will actually prevent you from pushing the code, which is super nice. You're really going left right here. What else do we have? We have something called, now we have GitHub Checkov Actions, right? If I go here, go back here, now we have, so the same Checkov demo file, I actually have a sort of workflow, right, with Checkov action within it, right? So this is literally that action. What does it do? Like for every push or every pull request, it runs the checkout, and then it runs the checkoff action. more or less the same thing that we've seen in the pre-commit. So you can add directory, quiet, or any other. It's like a bunch of other arguments that you can add in here. So it will run it. It will scan the content anytime there's a push or a pull request. And then the second task that is called upload serif, which is self-explanatory. You would just call git the code QL action upload serif function, which actually just is going to extract that serif file, and after that just make something out of it, like process it and then push it back to the security scan. So let's say like I add something. We don't have time actually to run it from scratch, but let's say we changed something, we did a push, and then you can see here that the action of Checkov is failing because by default, if there are failures, you got a non-zero exit. If I want to use an exit, the soft fail, this will just run until the end, right? But you still have the serif that is uploaded, right? And by the way, you have two jobs. When you call this code QL, there's a dedicated job. So it's not just one pipeline, it's two pipelines, one dedicated to code QL. That's what I realized. And after that, you go to code scanning, and then you get them. Every time you modify something, like I pushed from this file, even though I scanned the whole directory, that's the only file that would be that the checks will be taken from. Even though you can see that this scanned everything, you can see AWS S3 bucket data, but that's what I realized. Code scanning is just going to extract wherever is dedicated or related to the file that you changed. It's a pretty interesting observation because I didn't know before, right? And after that, once you need to do a PR, and when you do a PR from another branch, apparently there's a bug that I've been told from Palo Alto Prisma people. So you need to do a PR, accept it, and then you can use Checkov to actually protect your branch. So you go to branch protection, right? And then you can select require status check to pass before merging. This will actually go, and you find that it will list Checkov. So the checks, the status check from Checkov action, every time you want to merge a PR, will actually run. And if ever it's not complete, it's not successful, it would prevent you from merging. So this is the branch protection. It will protect your branch from being merged into a branch that matches the rule, and it uses Checkov. If it fails, then there's no way you can merge it. So this is the kind of protection that is added automatically with GitHub Action, and I really like that part, by the way. Okay, back to the slide, I guess. And let me see. I just want to share again my screen. All right. There you go. And then share the screen. Where do we get? Right. Window, entire screen. Let's go. Right. Okay. So if you have any question, just hit me up. Right. These are my socials, brocktba.com. That's the website. Twitter, clouddude_, and brocktba and GitHub. And obviously, TechBeats Unplugged. That's the place to be if you want to hear about tech. Thanks, everyone. And looking forward to answer your questions. Thank you.